Okay, let's look at these problems on moles. So the first question is, calculate the number of carbon atoms that are present in 0.500 moles of carbon. So here, there are certain things that you should already know, and that is given, and that's the equality. So we are first of all looking at the number of carbon atoms. That means we are talking about the Avogadro's number, which is 6.022 into 10 to the power 23 atoms. Okay, so these many atoms of carbon is equal to 1 mole. Okay, and knowing the molar ratios or the mole to mole, like the conversion factors. So we would see, I'm going to just put this as 6.022 into 10 to the power 23 atoms of carbon over 1 mole of carbon, over 1 mole of carbon. And the other conversion factor is 1 mole of carbon over 6.022 into 10 to the power 23 atoms of carbon. Okay, so these are the two conversion factors. Now we are given the moles. We are given the moles of carbon, and we need to find how many carbon atoms are there. So you're going to write down the given, which is 0.500 moles of carbon, and you need to find the number of atoms. Therefore, you're going to pick that conversion factor that allows you to cancel out the moles so that you are just left with the atoms. So this conversion factor you are going to use. So use this number here. It's 6.022 into 10 to the power 23 atoms of carbon. Okay, so this is an over 1 mole of carbon. So you see the moles and the moles diagonally, they cancel out. So here the moles of carbon and the moles of carbon is cancel out, and you're just left with the atoms of carbon. Now, how are you going to solve them? One option is that you can just put these numbers in these scientific calculators, and you can just calculate from there. Another one is you can do this 0.500, first multiply that by 6.022. Okay, and then leave this 10 to the power 23 on one side. So I'm just showing you manually, and then you can get the answer. Hold on. So the answer here is 3.011 into 10 to the power 23. Okay, atoms of carbon. So that's how you will, you will do it. That's the answer. All right. Okay, let's look at the next one. Moles of iron in the given number of atoms of iron. So it's the same story. You're going to use that conversion factor that allows you to cancel out the atoms so that you can get the moles. So 1 mole of iron over 6.022 into 10 to the power 23 atoms of iron, or 6.022 into 10 to the power 23 atoms of iron. Okay, let me just, I need space. So atoms of iron over 1 mole. 1 mole of iron. Okay, so you want to cancel out the atoms of iron. So this is the conversion factor you're going to use, and you want to find the moles. So the moles is on the top. So you will write down here the 5. So given 5.22 into 10 to the power 23 atoms of iron, multiply by that conversion factor, 1 mole of iron, 1 mole iron over 6.022 into 10 to the power 23 atoms of iron. Let me move this a little bit up. here. Okay, so now what we're doing here, we can cancel these out. The atoms of iron and atoms of iron cancel out. And now 10 to the power 23 and 10 to the power 23 also cancel out. So all you're left now is with the mathematically, you are left with 5.22 divided by 6.022, and whatever the answer is here. So let's get that one. So when we divided it, 5.22 over 6.022, I get 0.866 moles of iron. Okay, so that's one piece. Now, whenever you're doing these questions, you should always check the answers also, just so you are doing it right. And just to show you here, this is the answer. And here, this is the answer. So at the back of the chapter, right here, all the answers are listed. Okay, so we have done, which one was that? Right here. So it's 3.01 10 to the power 23. That was 7.29. So the first answer, that one. And then the next one was, which one I did? I forgot which one was that. 0.866 moles of iron. Oh, yeah. So 0.866 moles of iron of 21. So let's see. Sorry. Sorry about that. Okay. So the next is C, 0.867 moles of iron, which is fine, sometimes. So it's 0.88, I'm getting the C. Okay, so always check your answers. Anyways, let's move on to the next ones. Now, moles of hydrogen in 2 moles of H3PO4. Now, this is a parts to whole question. Here you see that H3PO4 is one big molecule, and it contains 3 moles of hydrogen are present in 1 mole of H3PO4. Okay, so in 2 moles of H3PO4, which ones are? So the other conversion factor is, since I don't have the space, you can just flip it. But you are going to use that conversion factor that allows you to cancel out the moles of H3PO4. So write down the given. The given is 2.00 moles of H3PO4, H3PO4. Multiply by, we need to find the moles of hydrogen. So moles of hydrogen, so in 1 mole of H3PO4, we have 3 moles of hydrogen. Okay, so that becomes the conversion factor. So this allows you to cancel out the moles of H3PO4, and you are just left with the moles of hydrogen. So next thing is, you just have to do a multiplication, which is 2 times 3 is 6 moles of hydrogen is present. Okay, so that's the answer. All right, that is the answer. And that's the answer. Hold on just a minute. I think I made a mistake. Hold on. Okay, guys, so sorry, I made a mistake. I forgot about that. It was 10 to the power 22 and not 10 to the power 23. So that was a mistake I made initially. So anyways, 5.22 10 to the power 22, and you have times 1 mole over 6.022 10 to the power 23. Now, if you put all this in a scientific calculator, you will get the right answer. But if you're not using that, you're just doing it manually. So how do you do? You're going to first take the numbers, the 5.22, and divide that by 6.022. So here you get this 0.866. However, you have 10 to the power 22 and 10 to the power 23 dividing. So whenever the exponents divide, they basically subtract out. So here, big number is being subtracted from a small number. So you have a negative one. So now you are going to take this and move to a scientific calculation. So sorry, you're going to move it. You can make it into a scientific, scientific also, and that is, you can move it and put it like this, like here. Then this becomes 8.6. 8.6. But the given answer is not in scientific notation. So what does this mean? This means that 0.866 is being divided by 10. This is what it means. So 0.866 divide by 10. And that's how you have 0.0866 as the answer. Okay. So if you use the calculator, then you can get it, but always write down what it is. This is the moles of iron. Okay. Sorry about this. All right. So anyways, we got it earlier. So next is, let's look at this, atoms of oxygen in 2 moles of H3PO4. Okay. Now here you have in 1 mole of H3PO4, 1 mole of H3PO4 contains 4 atoms of oxygen. You can also say 4 moles of oxygen. It's the same thing. Okay, so 4 atoms of oxygen are present in 1 mole of H3PO4. You can create the conversion factor. 1 mole of H3PO4 over 4 atoms of oxygen, or 4 atoms of oxygen over 1 mole of H3PO4. All right, so write down what is given to you. You are given 2 moles of 2.00 moles of H3PO4. And because we need to find the atoms of oxygen in 2 moles. So we know that 4 atoms of oxygen are present in 1 mole of H3PO4. So here you cancel out the moles of H3PO4 and moles of H3PO4. And what do you get? You get here 2.00 into 4 atoms divided by 1 mole. Okay, divide by 1. It's not even mole. So this becomes 8 atoms of oxygen. Okay. Next is the question on molar mass, and this is the answer. Okay, so you should always show it like, like that. Okay. Next is calculate the molar mass. So how would you do that? Here, you're going to need the periodic table. So refer to the periodic table. This 3 applies to magnesium. This 2 applies to phosphorus, and it applies to oxygen. Okay. And this 4 only applies to oxygen. So what does this mean? So this means we have 3 magnesiums. We have 2 phosphorus in this molecule, and 4 times 2 is 8. We have 8 oxygens. So 4 times 2, let me write this down. 4 times 2 is equal to 8 oxygens. Okay, so times, and times. Now let's look at the mass of magnesium. Magnesium is, I need the masses, sorry. Here. So magnesium, the mass is 24. Okay, magnesium is 24.3, you can use 24. Mass of oxygen is 15.99, you can use 16. And then P, phosphorus is 30.91. Now this one you can round up, make it 31. Okay, now let's get this here. Magnesium 24, phosphorus 31, and oxygen is 16. So what do you get here? You have 24 times 3, 24 times 3, and you get 72. So 72 grams is coming from magnesium. 2 times 31, 2 times 31 is equal to 2 times 31 is equal to 62 grams. And then 16 times 8. 16 times 8 is equal to 128. Okay, grams. Now you add all of this. So 72 grams, 62 grams, 28 grams, 72 coming from magnesium, 62 coming from phosphorus and 128 coming from oxygen. So 128 plus 62 plus 72. And you get 262 grams per mole. This is the molar mass. Okay, that's the answer. All right, so that's the answer. Okay, next is 41 grams. 41, question is, how many grams are present in 2 moles of sodium? So this is a grams to mole question, grams to mole question. Always grams to mole questions or moles to gram questions, you would need the molar mass. So we are going to find the molar mass of sodium. So molar mass of sodium is equal to, okay, sodium, sorry, which side is that? Molar mass of sodium is, you can see here, the periodic table, and here is the sodium, and 22.98, you can make it 23, okay? Now, let's do this here, 23 grams per mole. Okay, what is the meaning of that? This means that 23 grams of sodium is present in 1 mole, is equal to 1 mole. And you can create 1 mole of sodium, and you can create the conversion factors using this. So 1 mole of sodium over 23 grams of sodium, and 23 grams of sodium over 1 mole of sodium. Okay, so now you have 2 moles of sodium. So 2.00 moles of sodium times. Now we need to get rid of the grams, right? We need to find the, moles. We need to find the grams. So you're going to put 23 grams, the entity that you want to find, or the units that you need to find, go on the top, and the units that you want to cancel out remain at the bottom. So here we have the mole, 1 mole of sodium. Okay, and here you just get this, moles of sodium cancel out. So 23 times 2 is equal to 46. So 46 grams of sodium, and that's the answer. So always write the units and everything. Okay, that's the answer. All right, next question is the grams. Find the grams. You're given the moles of Na2O. So here you're going to take the Na2O, find the molar mass of Na2O. Okay, molar mass of Na2O. So what does this mean? This means that there are 2 moles of sodium and there is 1 mole of oxygen in this. The sodium, the weight of sodium is 23 from the periodic table, grams, and oxygen is 16. Okay, so here we have 223 times 2, and that is 46. So 46 grams is coming from sodium and 16 grams is coming from oxygen. So add the 2 together, 46 plus 16, and you are going to get 62. So this is 62 grams per mole. And that is Na2O. Na2O. Okay, so we have now how many grams? So 1.75 moles of Na2O. Okay, times, because we need to find the grams, so 62 grams of Na2O will be on the top. We need to cancel out the moles, so moles of Na2O will be at the bottom. And now you are moles of Na2O cancel out. And you have now the scenario where you take 1.75 times 62 times 1.75, and you get 108.5 grams of Na2O, and that's the answer. Okay, so that is the answer. All right, next is how many moles are there in 50 grams of silver. So here you're going to take the problem of question number 45. So 50 grams of silver. So same thing, you're going to take the molecular weight, so grams to moles. So you need the atomic weight of silver, which is 108. So just to show you, silver Ag is here. So it is 107.8, and you can make it 108. So it's okay to round up. So write down, so 50 grams of silver. Now, since you get an idea now, I'm not going to write down the conversion factors, but here now we have 1 mole of silver, because this is what you need to find. The find is always on the top. Grams, so 108. This is the molar mass of silver. The molar mass of silver goes in the bottom. And so here you are going to cancel out the grams of silver and grams of silver. Cancel out. So now you have 50 divided by 108. 50 divided by 108, and that is equal to 0.462. So answer is 0.462 moles of silver. And this is the answer. Okay. Okay. Now, next question 47 is, how many moles are there in aluminum hydroxide? Now here, you're going to, again, same thing, find the molar mass of aluminum hydroxide. So in this case, we have 1 aluminum. Remember, this 3 applies to oxygen, this 3 applies to hydrogen. So 1 aluminum, 3 oxygens, 3 hydrogens. Let's see. Oxygens, hydrogens. Hydrogen is 1, oxygen is 16, aluminum is 27, but double check. So here is the aluminum. So the mass of aluminum, as you can see, 26.98. So I made it into 27. Okay. Oxygen was 15.99. So I took 16, and hydrogen is 1.00. So here is your, sorry. So here is 27. Okay. So let's do this. So 27 plus 16, 3s are 48, plus 3 is equal to 27 plus 48 plus 3 is equal to 78. So this is equal to 78 grams per mole. Okay, so now we are given, let me do it in a different color. Now we are given the 25 grams of aluminum. So 25.0 grams of AlOH whole thrice, multiply by, we need to find how many moles. So moles go in the numerator, moles of AlOH whole thrice over, over the molar mass of aluminum hydroxide, which is 78 grams of AlOH whole thrice. Okay, so we see here, by doing that, the grams of aluminum hydroxide and the grams of aluminum hydroxide cancel out. We're just left with the moles. So 25 times 1 divided by 78, or in other words, 25 divided by 78 gives you 0. Excuse me. So the answer here is 0.320 moles of AlOH whole thrice. All right. Now the last is question number 47, moles of sulfur. Now here they are giving you how many moles of sulfur are in 2 moles of Al2S3. So it's a parts to whole question. So we know that 3 moles of sulfur are present in 1 mole of Al2S3. Okay, so the conversion factors are 3 moles of sulfur over 1 mole of Al2S3 or 1 mole of Al2S3 over 3 moles of sulfur. Okay, so 2 moles. So we are going to use that conversion factor, which give you the moles of sulfur. So this is the one. I just needed to show the other one, but we will use this one because that will allow us to cancel out the moles of the given Al2S3. So you are given 2 moles of Al2S3, okay, times, now here, 3 moles of sulfur, 3 moles of sulfur over 1 mole of Al2S3. Okay, so here, moles of Al2S3, moles of Al2S3 cancel out, and you have here 2 times 3 is equal to, the answer is 6 moles of sulfur present in. So that is your answer. Okay. All right. So always write the units and in what context. So we are going to do the other questions, which is 57, 59, 61, and then 63, 65 in the next video. All right. Thank you for watching. Bye-bye.